Hi, my name is Deepak Rana, and I'm Director of Systems and Technology Group, Systems Engineering work we do, and I'm within Market Development Organization, which Lynn runs, so Lynn is my boss. So the purpose of this group that we have is deploying, developing technology solutions towards commercial deployments, everything that Lynn was talking about in support and advocacy of that, enabling technologies, enabling solutions, and towards commercial deployment. A little bit of my background, 25 years in the industry. I started off my career as a hardcore researcher in IBM. I was on the first founding PowerPC team. Then I worked on things including compression, decompression, high-def TV, the whole standard works around that. Then in marketing, and for a long time I've been in communication. So some of the companies include Ericsson, Lucent, IBM, and I've been in Intel for a while, focused on the communication. So to quickly touch on that, I'll start with a bit of an introduction. Before I go there, this room is full of all the experts in the industry, but just it's a bit of a teaser quiz. If it takes Google, it takes Google X pennies or X whatever to move one bit of information from place A to place B. What might that number be for a typical service provider? Any ideas or thoughts? So suppose it costs X, what is that number, the multiplier? And it's a very powerful thing which I'm going to relate to enterprise cloud and the telco side, what the dynamic is and what these companies are up against. Any guesses on the number?
I think it's X plus Y. Whatever amount that is plus something.
It's okay. Any other guesses? Pick a number. It's a shocking number.
10x, yeah. 1,000.
10, another bit.
1,000.
Okay. The actual number is between 2 and 10x of what it costs Google to move. So I can share Google because that's public knowledge. I'm not sharing names of the companies because proprietary. So here is the situation: to move same amount of information, bit from A to B, whether it's voice, data, content, SMS, you name it, it costs them 2 to 10x. Now comes in the second grapple. Google offers that service for free, and they have to offer it for price. Next step, companies like WhatsApp and others are over-the-top service providers are eating the lunch of these service providers alive by offering their value-added services. This is the challenge in the communication service provider segment they are facing. And now I'm going to relate it back into the enterprise and the cloud side, how it all came about, where things are, and specifically what Intel is doing, investing in this whole space from the point of view of very heavy investment in technology, as Lynn was pointing out, very heavy investment in reference platforms that can be used to accelerate the deployment, and last is enabling the deployment of that so the technology gets deployed. So Lynn went over this, so I will not rehash into it. At very high level, network transformation towards software-defined infrastructure, purpose-built hardware on the left-hand side. To put in perspective, some of these hardware, these fancy core routers and all, they go at price points like $10 million plus. That's the hardware cost. And then the annual deploy maintenance cost running $2, $3, $4 million. I'm talking about one box. So that's why the multiplier 2 to 10x comes about. From that, next level after that is abstracting the hardware and towards softwareization. And then the last is using the concept of resource pool and then orchestrating it. The unified management concept Lynn was talking about coming from the data center side and comes from orchestration from the communication side. So from the left-hand side, gazillions of dollars, to the rightmost side, off-the-shelf commodity hardware, interchangeable into usable software. How do you go about? This is a bit of an evolution of network functionalized NFV and SDN. So these we call as the two twins of the same DNA, and I'm going to relate to why One side came from the SDN software defined network side, and the other side came from network function virtualization. One is ahead on one side, one is ahead on the other side, how it comes about. So prior from now before, this whole concept of softwareization, instead of implementing a function in purpose-built hardware, let's start implementing it in software, we can program it. I'll use an example. Some of the people here might remember companies like US Robotics and Hayes modem and all. Those modems used to go 300 bauds and used to go for $2,000. Then they all got suckered into the software. Remember companies like C-Cube used to make MPEG decoders. They used to go for $1,000 plus. That's just a software function, and then it became a hardware acceleration. That is what's going on in softwareization. Virtualization is obvious. Now I have made it into a software. I have a pool of processors, the VMware model. How can I optimize any unused resources to be able to deploy and use them? Cloudification, instead of virtualizing on hardware distributed on each desktop, can I move them into an aggregated place where I can purposefully reuse them across all? And then the last is decomposition and distribution. Can I take a larger function that I want to implement into micro functions, distribute them, and completely use them? I'm going to come to a very nice example momentarily. This is the telecom world's view, how it was prior to 14, 15, and 16 and beyond. That's what telecom world thinks are planning to go. Here is an itsy-bitsy problem. Some in the cloud world are more than 5 years ahead. Google deployed their software-defined network infrastructure and publicly disclosed it in 2013, in which they have global data centers across the planet where they can move their workloads as the sun moves. So as is daytime in the United States, the data centers in China are active and vice versa. So they can move their workloads that efficiently, and they have a near perfect network utilization. This is what is in the play. Again, I'm going back and forth because I want to relate this dynamic taking place in these three marketplaces, and then I'll quickly go into some solutions and some of the challenges that are out there. This used to be a typical universe of the telecom service provider commercial deployment process. You'd start with a proof of concept, then it goes into a vendor validation lab. When I say vendor, these are Ericsson's, Lucen's, HP, you name it. From there it will go into a service provider's validation lab. These are AT&T, Verizon's. From that it goes into the commercial field trial process, staging outside in the field. You stage it, then you do a regional deployment. Please keep in perspective, while it was very nice, Google world is doing extremely well, but Google is a walled garden, completely self-contained company which is global across the planet. It is not subject to the same regional regulatory environment. Example of China Mobile or China Telecom, 500 plus million customers, but they're still regional, they're not global, and they have to live within the government regulated environment. So this is the contrast, the challenges they run up against. AT&T, Verizon, literally minority companies. Now from a world population point of view, serving 200 million customers, doesn't matter so much. So given that, going into regional deployment with ability to roll back if something goes wrong, hey, lights out. I lived a nightmare in Ericsson where a senior vice president lost job for a regional deployment occurred, and the whole China Mobile regional network went south. And it was Vodafone on the hook. So life can be pretty dang miserable. And then into production. These cycles, typically in the telecom world, could be more than 5 years in process. And I saw in the bio of one of the person, at least one person here in the audience comes from DevOps area. Now the desire is turned completely upside down by the data center and the cloud world. So different facts are being put out, but companies like Google, Facebook, etc. supposedly turn multiple applications a day and try it out. So they're literally doing a field trial multiple times during a day. So that's the efficacy against which the telecom service providers are fighting against. Sounds pretty bleak and hopeless. Let me go into a little bit of the evolution of NFV, because this is, you would hear a lot, NFV, SDN, Battle, Enterprise, Cloud. Here's the beauty. These are Siamese twins, they have common traits and common DNA. This is what used to be called enterprise software-defined networking. In the carrier world, it is called network function virtualization. If I go a little bit into it, looks pretty similar. I will not bore you. You are all experts in the area. Unified management, parts of that Lynn was talking about, orchestration on the right-hand side. So in fact, the DNA of the carrier side network function virtualization is, give me the goods of cloud and at the price point while I want my ability. I'm coming to that in the next slide. So this is the good news part. They have common DNAs and traits. Now let me share a bad news. They speak different languages. The one side of the world is enterprise CIO. The other side is the carrier CTO. Left-hand side talks about workloads, business continuity, and business agility. On the right-hand side talks about services, carrier-grade service agility. However, in the bottom, if you see, the diagrams look pretty similar. Lynn had showed a beautiful diagram. Data center on the rightmost side, what she was showing, and access points on the left-hand side. I just turned it around slightly. This maps almost completely to that other diagram, but they're coming from a different perspective. Data center is coming from data, I'm offering some computing, those services. Networking world fundamentally comes from connectivity, throughput, bandwidth, latency. However, I like to submit to you, these are two manifestations of the same problem. So it used to be I find it very interesting. Data center and cloud people talk about compute resources and storage connected by network. In Ericsson, they call it a router with caching. That caching means storage and buffering, nothing else. That's how they like to view the world. Completely same picture, just flipped inside out upon itself. Again, I will not bore you into the details of it. Some of the subtleties on the cloud computing side and the network function virtualization, data center, cloud, enterprise people, and the net communication people, where they come from. Here's a very interesting thing. Number 4, node-centric, shapeless interconnection. They don't worry too much about the connectivity. They assume connectivity exists. It is provided for. Right-hand side, connectivity is everything because the network is very regional, very fragmented. It is not uniform or homogeneous. Let's take a little bit further picture down here. Fault detection, up to a minute, it's okay. When you're using Google, something goes down for a minute or two, it's all right. Try doing that on AT&T or Verizon. There are serious penalties and covenants around it. Last, this is a very important point. I will bring it here because Edwin, the next speaker, is going to drill more into it. I'm going to relate to that concept. A concept of 1 to 2 gigabit per second, billion bits per second, kind of throughput is good enough. However, that kind of a bandwidth is child's play in the communication world. Google Fiber today is working on deploying 10 gigabit per second to the home. Imagine what the ramifications of that are on the central office side or in the core side. So that's a very key component of the challenges the two sides face. This slide Lynn showed, so I will not walk into it. The idea is the two technologies, two manifestations together is what is driving and transforming the infrastructure. This is the reality number 2. So one challenge I spoke with, enterprise and telco, they talk different vocabularies, even though the DNA is common. Here is the next problem. So in the communication, telecom world, enterprise and more importantly the cloud world went through solving the problem a while back and got to solving the problem. Lynn was referring to those as standard benchmarking, different tests, interoperability. They sorted that problem out. The world in the telecom side is more like a Lego world, Lego blocks. Pull them together, see if you can put it together. But there is no Google, a global company, which can pick all of it together and roll off its own as a closed system. So this is another problem that is faced. And now I'm quickly switching into what we in Intel are trying to do to alleviate and solve some of the problems.
I think I'd argue that one of the things with
the difference between enterprise and service provider, because I agree that the NFV and SDN solutions are fundamentally the same.
Yeah.
There's the difference is you have an enterprise who's trying to make money with the data, whereas you have a service provider who really doesn't care what goes over it. They need to make money from the data passing through it. And so the NFV thing, when you look at most of the service providers have realized that they cannot have monolithic centralized functions like firewalls and load balancing and so on because they don't scale. And they're pushing out to a distributed system, and the only cheap way to do that now, right, is to go NFV, and now it's a value-add service. Oh, you buy your MPLS circuit, you want caching, you want load balancing, you want IPS, it's another NFV spin-up and a bit of orchestration. That's a different focus, but it's all for them. It's all ka-ching, right?
Go on. I'm listening to you.
That's good. I think it's a slightly different purpose towards the same thing. Even within enterprise data centers, we've started seeing that the aggregation of the data center's throughput still can't come through a single point.
Absolutely.
And so you definitely end up, we go from where it used to be very popular to centralize your security, you end up pushing everything down to the edge because it's the only way it scales.
Yeah.
And that's, in hardware, that's really expensive.
Yeah. So, great, all the things you said, John, except for one interesting caveat. Mm-hmm. So when you mention service providers wanting to make money by moving the data, whereas the enterprise people buy services, that's where the reason is the following. You cannot stand steady. I give you example of WhatsApp. Carriers were making money through Wazoo. Some of the people here, I can see at least have kids that must be burning the budget through anything doing SMS. Remember 25 cents and 10 cents? They were simply charging money by pushing application. WhatsApp has destroyed that model, and more going on there over the top. So carriers standing still, simply wanting to make money off the pushing the bits, dead on arrival. I'll use another example. Netflix, beautiful free ride, right? Net neutrality. Netflix hosts its service on Amazon, the price that they charge, and they completely squat on the service provider's network, competing heads-on with Comcast and AT&T and Verizon. So for carriers and the service provider, a model where they're trying to get to is they cannot quickly move all the things you said, all wonderful, pushing out the security and everything to the edges. That is exactly where they see the values and possibilities are. The advantage service providers have, natural advantage, fundamental advantages. They own the customer. They own the pipe that feeds into the customer. So the place where they want to add value, they're trying to add value is on the edge. I'll share an example momentarily, what they call customer premise equipment or enterprise and aggregation of it. That's where they find value. Some companies call it fog computing, an environment closer to the ground, not in the cloud. That is all true. However, a problem they're facing is they are not Google and Facebook like, so they cannot have a global data center distributed the way you're describing. They're finding models of actually collaborating. Amazon, who would have thought of Amazon getting into providing NFV services, right, on Amazon Web Services? They are looking into providing that. So it's an interesting model. What I cannot do by myself, in which I do not add fundamental value to it, by putting $1 zillion in my data center, I will collaborate. All completely agree. However, service providers standing steady and not getting into providing contents and services, bad idea. An example, some people, a close friend of mine from Intel, very senior person, just left. He went and joined Google Access. Who would have thought of Google as a comms service provider? Now they're getting into Access, taking the war straight to the service provider side.
Right. And I think there's two kinds of service providers too, right? And you mentioned WhatsApp. So mobile service providers is a different kettle of fish because SMS was the world's biggest scam for the world's longest time.
Yeah,
right?
yeah.
It was all about, hey, I've got some free bits on a management channel, let's charge for that. So that was free money to them, and then, well, why charge you so much for data?
Yeah.
Well, we'll get you in. If you can't get you one way, we'll get you the other way. If I'm being cynical, right?
Absolutely.
Whereas your wireline service providers have a very different problem to deal with. So they don't have the same revenue generating operators that a mobile operator does.
Completely agree.
Opportunities rather.
Completely and totally agree. And that's also, you're absolutely right, but partly it is also reflected in the expenditure profile. On the mobile side, the expenditure is according to some, more than 70%. Intel is helping in alleviating that also. So let's go to the next one.
So just real quick, and I've gathered a few things here that are of interest, and please let me know if you're about to talk about them.
Absolutely.
But a few things of interest to me personally are some of the things that you touched on, and as well as you. Specifically, and this is something that I think only you might even be talking about right now, which is treating the network as a pool of resources instead of, you know what I mean? And I think a lot of that is because these things are increasingly done in software. More functions, more complexity is actually moving into software.
Yes.
I personally would love to see, I think, a little more on that side of things and more of the detail and what value you guys are providing there. In addition to, by the way, this is the other thing, your contributions and participation in the open source community. I'd like to see what you guys are getting out of that, as well as what you think customers are getting out of that from your participation.
So some of that material you are talking about, I have it in next 2 or 3 slides.
Okay, cool.
But some of it admin will cover.
Sweet.
And then what's left over, more than happy to follow up with the more details.
Okay, cool.
So exactly along your line, perfectly timed segue question into it. This is the beginning of Intel's investment in the network transformation. So rather than walk through all of words and all the detail, the way to look at this diagram is the top half of it is Intel's investment in the technology and the leadership in it, which is on the left hand side. Lynn showed quite eloquently, second but last slide, the entire industry consortia, open standard bodies. Intel, Sandro Rivera was one of the founders of OP NFV initiative. So this is through which Intel facilitates this open collaboration and investment into it by leadership, money, resources, and other such contribution. The top right hand side is also enabling, it's a reference design open networking platform. It's called Intel's Open Networking Platform. This is a reference design which is comprised of, I'll come to that, I'll use a beautiful metaphor in the very next slide, offering blueprints, offering an example, ingredient, how a customer or end customer can use it to develop their commercial solutions to deploy. Clearly, we are not competing with our customers. We don't compete with Ericsson and Cisco's and Junipers of the world. We assist them in the way they can make it cheaper, better, faster. So to put in perspective, the $10 million router example I was talking about, the price points where it is heading is a fraction of it. And that too in the near term horizon, not a multi-year plan. So top half is investment in technology. The bottom half is investment in enablement of it. The bottom right hand side is network builder, close to 170 partners in that, and it's a wide swath in the whole value chain, from components to software ingredients to infrastructure to functions to end service providers to integrators. Again, to foster that collaboration, Lynn used the example of PCIe Plugfest. It's along those lines to take it in that direction that you can literally turn on. And I have an example I'll use with the PC side. And the left hand side is, that's equally important. We are not Buddhas that we sit in a cave and suddenly come up with all these brilliant ideas. How does that happen is we actively participate in entire telecom, cloud, and enterprise POCs and trial, not just with our customer, but with the end customer. So my group is actively involved with both of those types. Why? To help them accelerating, but the reverse path, that knowledge that comes in, fed within Intel, so we can do better job at it. This is how people generally familiar with this diagram is the HC's unified world of the network function virtualization. The way to look at it is bottommost side, which is called NFV infrastructure. That's a hardware virtualization, host operating system and stuff comes in. In the middle, this is where application resides. Top is the legacy. In telecom world, legacy lives. Sonnet lives. In case of Verizon, I see there is one person from Verizon. Some of the Verizon data center are still, the interconnectivity control signaling is done in X25, X.25. I would be surprised if anybody here familiar with that, because it is so dang old. It is from 70s for crying loud. But it lives. If there is something put there, it will live forever. Right-hand side is simply a mechanism of controlling and orchestration. Today, this is only today's world. This is where Intel's OP NFV focus is. And very quickly, work is being done on the right-hand side because, okay, I have provided the infrastructure. Can you help me in building the whole system? That's where we're going. This part remains. This is where OP NFV Intel is going. And this part, last part, is this is where Intel's Network Builder program is about. So relate to that ONP platform I was showing earlier. Provide a platform you can work with. Provide the ingredients to go around. And foster a collaboration through the Network Builder program with which somebody can deliver, a customer can deliver a full-fledged system. Okay, next 1 hour I'm going to take going into every box and every word of this. This is not it. This is a fiduciary diagram. The thing which I want to just point out to here is that just look at the bottommost row, left to right, as time goes by. Each new generation of Intel ingredients, processors, NICs and such is faster, more integrated, lower power. So the way to visualize it, more and more and more value added in terms of throughput and performance. A 40 gig line rate just 4 years ago to develop a line card like that was a more than $50 million budget. And it used to cost more than $100,000. Edwin will show you in the next few minutes where he's going, how realistic it is with off-the-shelf commodity. Top side is simply different ingredients, a la carte or soups to nuts. Here is an example. An easy way to visualize this is think of the original PC development, how it came about. Leftmost side, a whole catalog of components and ingredients, what you can pick up from the menu. In the middle is Intel says, okay, here is a reference architecture. This is how you can assemble your PC. However, on the right-hand side, this happens to be an actual example of HP. They picked some of the ingredients, they work closely. They built on top of that using WinRiver's Titanium server, and this is actually a commercial product that they're building. So mutually beneficial, two-way street. We help them, they provide us insight. And it's only one example. This is not that it's HP only. We work with every vendor, every OEM, every TEM, every service provider. So think PC, think the places where they add value, the place where Intel plays most dominant role or a very powerful value added role is providing the infrastructure side, but it enables simultaneously the players above. So to your point earlier, this is where in the open source community, Open Daylight, OpenStack, DPDK, KVM, Fedora, this is still only one example of it. It's just whole list, laundry list where we actively participate, hundreds of people constantly contributing. Lynn can probably correct me if I'm making a mistake. Isn't Intel one of the biggest contributors to the Linux community?
Yeah, we're generally in the top 5 as just traditional contributions, kernel.org, SourceForge, etc. We're repeating what. Pardon?
Yes, Intel has a long history of contributing into the open source environment. We tend to be somewhere in the top 10, just depending on where other companies are falling and how many developers we have putting contributions in at any moment. But we've been committed to open source and being major contributors, both in the Linux environment as well as in OpenStack. We've been increasing our investment through some of the Cloud for All initiatives. And then we've also repeating that with the network contributions as well.
So I'm quickly running out of time. In the previous slide on the rightmost side that I was showing where WinRiver was shown, this is the example of it, how it is. WinRiver is an example of Intel's ONP taken to commercialization. Let me quickly share with you some results. I will not go into gory details of it. I like to share with one last slide. A key component of the ONP was to remove performance guesswork, a guesswork that deployer or a builder has, what will it take, what ingredients I make, what can I expect, how it might perform. Again, these are all disclosed in the open domain, and we publish them regularly. And connecting with Lynn's comment of industry standard benchmarking, we continuously keep on adding more to the test suite we use to harden, make it more tighter, more predictable, more performance oriented. These are some of the diagrams. We will be out of time, but effectively, the idea of this is there is a continuous path to performance improvement. And I like to connect here. In the beginning, I was showing in the data center world, 1 to 2 gigabit per second was considered good. Now the new norm is show me a path to 40 gigabit per second now, and have a clear path to 100 gigabit. To put in perspective, that is 30x this year, and whatever 80x going forward. And that's, Edwin will talk to it. Just to quickly summarize, it's essentially, I wanted to convey here was Intel's investment in open standards and technologies to enable reference platforms, ingredients, and solutions to remove the guesswork so the network transformation can accelerate, the solutions get deployed. Massive investment, massive. I'm standing here as a result of investment. I'm a cost center, I'm not a profit center. I'm simply in existence to enable it to happen, and it's a massive amount of money that I've burned for the company. But to develop revenue later, boss is standing here, right? Plan cycle is on. So, yeah.
So one thing I would like to just kind of reiterate to your question about open source contributions, the Fast Track initiative that we just announced is really focused on taking all of these optimizations that you can get out of Intel platforms for I/O workloads, and then we harden and test it and do characterization with real workloads and using real work and third-party partner software, open source software, whatever we can get our hands on. We do all that testing and characterization and put all those optimizations back into the open source community. Our goal isn't anything beyond make it easier for everybody to take these optimizations that are going into open source and then do a commercial deployment with them. That's the whole goal. And I know Edwin's going to be talking about some specific optimizations that we've been working on for a number of years that are very innovative and have taken off in the community in ways that we didn't envision years ago, but we're really thankful to see the momentum. So